Okay. So, last section of the chapter. Yesterday we talked about what?
I like watching you do this.
We talked about 3 types of yield, right? Which are what? Nope, that was it.
Theoretical yield, actual yield.
Actual yield, percentage.
And percent yield, yes, okay.
I don't really know the
Theoretical yield is how much we expect to produce from the reaction. Actual yield is what we actually get. Percentage is how they compare, right? Okay, and so today we need to talk about something called limiting reactants, because this is going to help us deal with how chemical reactions actually work in the real world. Okay, so let me start with an illustration, and then we'll do 2 examples, then we'll be done. Okay, so let's say we're going to react these 2 compounds and make some antimony 3 iodide. Okay, I've got some antimony, I've got some iodine gas, or solid, sorry, I'm going to make that. Okay, now we've learned so far that the coefficients in this reaction mean this, that for every 2 moles of antimony I need 3 moles of iodine molecules. It's a molar ratio, right?
Yes.
The thing, thank you, the thing is, in the real world, we don't ever actually have the exact ratio of starting materials that we need. If I were to actually do this in the lab, I would not be able to measure out exactly 2 moles of this and exactly 3 moles of this. It's just not physically possible. Okay? So, how do we deal with that? Okay, let's say we're in a situation where we have 2 moles of antimony and 2 moles of iodine. Okay, so instead of 2 and 3, I have 2 and 2. First question, does the reaction still happen? Does the amount of chemical actually affect its chemical properties?
No.
No. So it still reacts, okay, like Ethan said. Okay, it still reacts. However, we are going to not use them up both down to 0. We're going to use one of them completely, and then another one will run out because we have extra of one. Okay? And so if we're in this type of situation, we need to figure out, we need to be able to figure out which element is going to run out first. Okay? So the reaction will happen, but it will stop, and one of them will run out, and we'll have leftovers of the other. Okay? So the reactant that runs out is called the limiting reactant. And the one that has extras is called the excess reactant. Okay? This is the only thing that we need to know from this slide.
I wish I had Ethan brain so I could nap during class.
Well, Ethan doesn't nap during class.
But Ethan could.
No,
So if I had
Ethan cannot.
brain, I could.
Limiting reactant, excess reactant. We got this?
Yeah. Wait, give me a sec.
Okay.
should
Something
I
still
write-
tastes funny in this bottle. I feel like
Is
I'm
this
drinking
new?
soap or something. Yes.
Probably because it's
Oh, I'm
bubbly
dumb.
water. And soap has bubbles. It makes it water.
Well, it's carbonated.
Well, yeah, that's what I'm saying.
Also, I don't think it's connecting like it should.
Is it not? Is it out of?
Carbonation?
Yeah.
Maybe.
Because then it tastes funky. It does.
Really?
Yeah.
When it runs out?
Yeah, when it runs out of carbonation, because like at Dairy Queen, when the carbonation runs out, like all the sodas taste bad, and then everyone comes back to complain.
I have one of those, and if
It's
you
a
work at Dairy Queen,
carbonation.
I used to, then I quit because
Hmm.
it never worked.
I'll have to see if I can, if there's a thing on the tank that tells you if it's low.
I have another tank.
So why do you drink it carbonated is my question.
Because it tastes good.
Because it's fun.
What?
We have carbonated water at Diner 64. So
We
it
do?
tastes bad.
Club water?
Basically.
Or club soda? Sorry, not club water. Anyway, we're good with this?
No,
Not yet.
no.
Is club soda literally just carbonated water?
Yes.
Are you kidding me?
It's good.
That's why I didn't like it when I was little. Because I thought it was real soda, but it's just water.
People usually will mix it with stuff like punch to make
Or
it more
alcohol. I see, like, I watch bartender TikToks
Me
because it's
too.
so good and it's so cool. How do you
Yeah.
know that?
I
Well,
love bartender TikTok.
The club soda they put in their drinks at the very end.
Nice.
You put alcohol in that bottle of Floyd. vodka.
You would never know.
Same brain, Ethan brain.
If I ever start acting
He won't be the
loopy.
first person at the school to drink this.
Why do you think he gets super sassy sometimes?
I wasn't ready.
Sorry.
Well, he's nice to Aaron, but when we say wait, he doesn't.
That's because I will start to cry.
Did I not cry in this room like literally the other day?
I don't know, probably.
Some point.
I'm sure you did, I just don't
I
remember.
feel like I've cried in this room once,
Okay.
but secretly.
Okay, so we need to be able to identify the limiting reactant. Okay, so let's do an example. Okay, let's say I'm going to react some sodium hydroxide with some nickel 2 chloride. First thing I want to figure out is which one is the limiting reactant, aka which one runs out first. Because the one that runs out first is going to determine how much product I can make.
So the limiting reactant is which one runs out first?
Yes.
That is translation part.
Good. Okay, now it might be tempting to look at this one and go, oh, there's less of it, it's going to run out first.
No,
We
you have
do-
to do the equation and find out the ratio.
Right, because now it could run out first or it might not, okay? If we look at the reaction, which, any guesses what type of reaction this will be?
Ionic.
No, it's not an option.
Double this.
Double displacement. What are we gonna make?
Sodium chloride and nickel hydroxide.
Nickel 2 hydroxide? Do either of those precipitate maybe?
Nickel.
Sodium? No.
Sodium chloride is very soluble.
And
What about hydroxides?
there.
Oh.
Probably precipitate. Nickel hydroxide. Okay, so we've got this. So this one probably precipitates, but that's a side issue. Anyway, this is our reaction, okay? So it might be tempting to look at that and say, hey, there's less of it, it'll run out first. But
Can you move your arm?
pay attention to the coefficients. This one has more, but look, the coefficient 2 means it's going to be used up twice as fast as this one. So there's more of it, but it gets used up faster. So we can't necessarily be sure which one is going to run out without doing a calculation, okay? So let me show you those calculations so that we can know how to do this once I find my purple marker.
It's, NaOH runs out first because it's, wait, yeah, because it's 2 and it's more than double the NiCl. Right?
It's more than double?
It's less than.
Less than, sorry, I read less than.
Less than
so
double?
it runs out first.
I think you might be right. Let me show the calculations, because this one you can kind of look at and figure out. I think you're right. Let's do the calculations so we at least know how to do it, okay? So, first thing we need to do is take our amounts of reactants. Okay, I got 8.3 moles of sodium hydroxide. And I have 4.9 moles of nickel 2 chloride. What I'm going to do is I'm going to calculate the theoretical yield of either of those products that I want based on each reactant. Okay, so let's pick one of the products. Which one do you want to do?
I wanna do NaCl.
NaCl? Okay, we'll do NaCl. It is not 1.5 left over, Junie.
Okay.
You're close. Sort of. Not really. Depends how you define close. Okay? So we're going to take these and we're going to convert to NaCl. Okay, I get 2 moles of NaCl. Okay, because I'm using my coefficients. Molar ratio, 2 moles NaCl. Okay, for sodium hydroxide, there's 2 of that. And then 1 mole of nickel chloride.
Before you drink away.
I know. Okay, we're calculating the theoretical yield based on those 2 starting amounts.
Hold on, let me think about it for a second. How do you process it? Where'd you get the 4.9? Oh, okay.
Okay, so I'm taking this, converting to that. I'm taking this
So
and
the
converting to
2
that.
mole NaCl, are you the 2 in front of it, and then the 1 mole NaCl is the 1 in front of it? And
Molar
then-
ratio. Just
2
from
to
the
1?
coefficients. Yep.
And then the other, I don't
everything you said so far is correct.
So are we gonna have to do it again with 2 NaOH
Well, it's not.
and IOH too? Are we gonna
No.
have to do it again?
We just need one product,
Okay.
and it doesn't matter which one for this. We're just converting to product, right? We're converting this and we're converting this. Right?
Yeah,
Okay,
okay. Okay, I think I get it now. So
Okay.
you have to take both of them from that side because each of them.
because we have different amounts.
He said,
There's probably some weird last conversion.
Yes, no?
I don't get it.
What do you
but
not get?
Well, I'm thinking about too many things.
I have this amount and I have this amount,
Yes.
and I'm calculating how much of this I get.
Yes, I get that.
Okay, that's all we need to know so
No,
far.
I need to get the steps. Did I already get them?
Okay, so anyone got the answers?
Why are you using NaCl and not nickel too though?
It doesn't matter, you just pick one.
Either one?
Either one.
Always just one or the other?
Yes.
Isn't that gonna be a problem with both?
What's 8.3 times 1?
That's
One,
2.
That's a 2.
That's a 2.
Divided by 2.
Oh, cancel. Wow.
8.3 moles of NaCl.
And then it's, no, I got it.
Jeez.
"Did you stop yelling? Jesus."
This is gonna be 9.80? No. 9.0.
What?
Six of you and I.
How about 9.8?
That's what I said. Oh,
Why
there's
do you
no
make
0 at
your
the end?
eighth like that?
Because I'm sideways. Okay.
Why wouldn't it be? Why aren't you putting the zeros?
Yeah,
You
see, because I
understand
was
that
on
it's
the.
the
Because it
last
doesn't,
one and
okay,
that's
because
really-
the question is not asking for amount, so it doesn't really matter.
Okay.
But
Yeah, it is. How much is that? Sure, yeah.
that's not what we're calculating right now.
Are we adding it now?
We're answering this question right now.
Which is the limiting, which is which one that runs
So,
out the
NaOH.
I can't tell if she's telling a story or if she's actually,
Well, either way, you can.
she's fine.
Oh,
Okay, so if we use up all of the NaOH, we get this much product. If we were able to use up all of this, we would get this much product, okay? The reactant that makes the least amount of product is the limiting reactant.
Okay, so even if you used NiOH, it'd still be the same, like you'd still get the NaOH?
Yes,
without
you'd
that
still
part?
get a smaller number for this than this.
Okay,
It would still work out
it
the same.
doesn't matter.
It does not matter. Okay,
Unless
So-
you mess up or something.
sure. Okay, so this is the limiting reactant.
Or you just got a 50-50 shot and you can just guess.
Yep, and then it messes up all the other stuff after because there's questions that come off of it.
Oh.
So I wouldn't do that. Okay, so we okay so far?
No,
What?
I think I understand it, but I'm gonna need help.
what?
I can't do it on my own, but I can do it with assistance, I think.
What is your question?
Aaron, what kind of smoothie do you get?
Okay,
Banana boat.
so we figured out which one is the limiting reactant. This one will run out first, okay? Now we need to answer the question, how much of the leftover are we gonna have? So this one is in excess, meaning extra. We will have leftovers, and I wanna know how much leftover, okay? Here is how we calculate the leftovers. You need to take your limiting reactant.
I'm just kidding. I'm just kidding. No one take that literally.
Okay, we're gonna take our limiting reactant, we're gonna convert to the other reactant to figure out how much we use up. Okay, so I'm gonna convert to moles of NiCl, 2. Cancel my moles of NaOH. What's the
Now
molar
we're-
ratio?
wait. Hi, hello,
What?
remember me. What's happening?
Okay,
Oh, I know this
I
one.
was explaining while you guys were talking to each other. We're
It's
trying to
one-
figure out how much of this is left over.
That one says the 1 mole on top.
Good,
The next one is 2. And
Good.
right here inches.
good.
And then half of that is going to be about 4.15,
Very nice.
something like that, 4.2-ish.
No, one.
And you can do 1.5?
Yes, you're allowed to do that.
Okay. Well, last time I
So
was
this is
wrong,
4.15 moles
I
of nickel chloride used up. How do I figure out how much is left over?
Drag.
Subtract.
Subtract from what?
From the big number,
What's the big number?
8.30.
Nope.
Oh, 8 point,
4.90.
thank you.
What's 4.9 minus 4.15? Moles, nickel to chloride left over.
Okay, why that one?
Why what one?
NiCl2.
Because that's the one that's gonna be left over.
Jesus.
Is that the one we chose from last slide?
Yes,
Okay.
Wait, what are we subtracting from?
the starting amount.
It's called the
Oh.
excess reactant, is the one that has more left over, the one that runs out.
XS
longer.
is short for excess.
But excess doesn't make sense because that means extra small. And excess
If you're a
means you
shirt.
have plenty.
You're making some nickel chloride.
Extra small means you have extra food left over because you didn't eat it. Never mind, bad joke. Okay.
I don't get it.
Questions about this chemistry problem? Yes.
Oh,
Okay,
it's
take that
bad,
as a no.
not because it's a like bad joke, like a dark humor joke, but it's bad because
Oh my gosh, are we gonna have to
it's not a
do this
good
while
joke.
changing through grams?
Yes.
I can do it right now.
I think we deserve.
Are we doing that today?
Yeah, I definitely agree
You
with
said
Kenzie
there were
there,
two.
except I'm gonna finish her sentence.
I said
feel
two
like we
examples.
should just stop here because we deserve it, and also because I barely understand what we're doing now, and I don't
You
understand.
deserve
Take
nothing.
offenses.
Okay. Anyway,
Oh,
this is
okay.
the last example. Last example.
And we're going to grams or moles,
Okay.
one or the other.
Because we need to work our brains. Okay, so I have 1.002 grams of aluminum and 1.002 grams of oxygen.
How do you have grams of oxygen? It's not even there, man.
Air has mass because it's made of atoms.
But it doesn't weigh anything.
False. It does.
So you're telling me I don't actually
So I
weigh
am.
whatever I
Is it
weigh? and
gravity?
that
Is it
it's-
like the force of gravity?
Yeah.
Is that?
Yes. Yes. Air pressure applies, pushes down.
Okay, so whenever it's windy out, does that mean
That's
the
why it
air
doesn't
pressure?
float away into space.
Is that why the air gets, does the air get heavier when it's windier?
No, it weighs the same
Okay, then
How
why
is
does
wind
it
made?
go harder?
because it's moving fast. It's applying a force. It's pushing you.
How is
If I punch someone in the face, my fist didn't get heavier. I just applied a very strong force to them.
I think it's
That is a
because
good
it's
one.
heavier.
Force equals mass
I
times
think we should test
acceleration.
this.
But
Mass
your
is
fist
constant,
did
but
get-
the
like,
acceleration
If you
of
put your
it.
weight behind it, then technically your fist got heavier.
No,
Yes, because your fist, like
it
you
applied a.
chopped, you chopped off your fist. It only weighs like this much. But
Okay,
if you
if I
like,
chopped
do
off my
not
fist and threw
Then-
it at someone with my other hand, it wouldn't get heavier.
no.
That's what
but like
you
a
think.
punch could get heavier.
No, it's a stronger force, but it's not heavier.
I mean, technically you'd have a
Heavier.
larger amount of mass behind.
Have
Okay,
you
wait, if you
weighed
have
your
a
arm
scale,
while you're
right, you have
punching
a
someone in
scale,
the face?
and you place your fist on it, it'll weigh one thing. But if you punch it,
That's
it'll
because
weigh a
scales
different
are-
amount.
Correct,
That's
but you're
because
not
scales
measuring
are
weight.
based on force, not weight.
You're,
Jimmy, you have a problem.
I caught myself. I caught myself.
How does wind?
What did you catch yourself doing?
All right,
How do you
I was
make
gonna say
wind?
your mom. It's based on.
you don't. The earth makes wind.
How?
It rises and then it fills the space.
When God sneezes.
Or the devil. Depends on.
Or when God farts.
Okay, are we ready to do the
Yes.
chemistry?
God.
Okay, the answer is yes, even if it's no. Okay,
I don't know.
I have this mass of oxygen, even though it's a gas, and I'm gonna react it with
It's
aluminum.
9.8
Here's my
meters
equation.
per square foot or something.
No. Anyway,
My math just says.
my first step is to take these grams and convert them to moles, and we'll make a side note. I forgot to do this in second hour, and it was wrong, or it just was tedious. So to save ourselves some time, we should convert to moles. Okay? How do I convert to moles?
Divide by molar mass.
Divide by molar mass.
Your
in-
handwriting actually looks semi-decent that way.
Thanks. What's the molar mass of aluminum?
13.
Nope.
26.9815.
What about oxygen?
15.99.
That is one atom of oxygen.
1.002.
Oh, 31.
Yeah, 31.998. Because it's O2.
So you have to multiply by 2?
Yes, because the mass doubles when you have two atoms.
Wow.
Can someone calculate them for me? Give me 6 sig figs.
Oxygen should be
Why 6?
988 knots.
Start over, Junie interrupted.
Why 6?
The first one is 0.037.
Oh,
One,
okay.
3, 6, 137. Cause you said 6 figs.
That's 5. I need one more.
Okay, 6.
Thank you. Moles of aluminum. How much oxygen do I have?
Do I have?
Ethan did it.
Oh,
No.
no, I was correcting your previous oxygen count.
That is
There
7
used to be
sig
another
figs.
8 at the
Kinsley
back.
is right.
Yeah.
0.0313146. 2 4 is not 6. What?
1, 2, 3, 4, 5, 6.
Can you fix that one?
Yep.
1, 2, 3, 4, 5, 6, 7. There's 7 there.
6.
No, because both the zeros are.
Rounded up to 37.
But I thought everything
don't
after
count.
decimal counted.
No, except because leading zeros never count.
I don't.
Okay.
I've got 1 month of school left.
Okay, the reason I kept 6 sig figs is because we're not at the end yet. I'm gonna take those numbers and plug them into another calculation.
But nothing
And
else.
so I want to keep extra digits so I don't have rounding error. Because if you round every step, the answer is gonna be really rounded off.
I thought you kept 6 sig figs since both aluminum and oxygen have 6 sig figs.
That does, what do you mean, their masses?
Yeah.
No, that's a coincidence.
Sad.
Sad. Okay, so I've got my moles. Now we can do the exact same thing as last time. What was the first thing I did to figure out the limiting reactant? What do I need to do with those moles?
You make a molar ratio. Yay.
And convert to what?
Your mom.
Try again.
You kid, what?
Grams.
I don't know.
Yeah, let's convert back to.
I
Oh, wait.
just converted from grams.
Oh. Left
You made
to
a
aluminum try whatever it is.
I'm
AlO3.
Yes, because I need to calculate the theoretical yield for each one. So I'm gonna go to moles of aluminum oxide. Moles of aluminum oxide. Figure out how much we would make theoretically if I could use it all up. Marker's
So and then
dying.
so 2 moles over of Al2O3 over 1 mole of aluminum.
No,
No. 4. Sorry, I meant 4.
good. 2 moles of aluminum oxide over how many moles of oxygen?
Oh, 3.
Very nice. Okay, and I'm gonna see which one makes less. The one that makes less is the limiting reactant.
It's gonna be oxygen.
I don't know, we gotta calculate.
First one is 0.0185683.
Okay, next one.
Point 0.20896 7.
you like breaking, you like, when the rules are arbitrary.
Wait, then it should be 0.0189 and
Yes.
0.01.
But which one's less?
First one.
The first one. All we care about is figuring out which one's less. So why use the sig fig? So what's my limiting reactant?
Your mom. Aluminum.
Aluminum is the one that runs out first, so that is the limiting reactant. Very nice.
Extra small reactant is oxygen.
No, and then oxygen is going to have leftover, so there's excess.
Extra small.
Extra small. Even though it's extra big.
Yes.
It's confusing like that, okay? Great, so we did the first part of the problem. Now we need to figure out how much is left over.
Minusing.
That's going to come at the end,
What the fuck?
okay? You're on video right now.
0.020897
Okay, so
divided by.
I'm going to take my limiting reactant. Is that what Junie's saying?
Yeah.
You wanna cut that part out?
Not really.
You really should.
Seems like a lot of work.
It is a lot of work. I video edit. It's a pain. Okay, I'm going to convert to the other reactant to see how much I use up.
I'm all out of room.
Alright, so moles of
Wait, what?
O2 from my moles of aluminum.
Okay.
Because we got to figure out how much we use up first.
Yeah.
Alright, so my ratio is
4 to 1.
4.
Wow, by 3. 1 to 4. Oh, I didn't see the 3. I thought that was
3 to 4. Okay, now we actually care about sig figs for this one.
How many do we need? 1,
4.
2, 3, 4, 5, 6. That's 7. Oh.
4.
Equals 4 times 0.02785.
Moles. Oh, whoops. We're subtracting from grams, right?
And so now we have to.
So we added, I forgot, the picket fence needs one more step because we got to convert to grams. Ah, gosh darn it.
That's what I'm saying there.
1 mole O2 equals.
31.9988 grams.
I don't know.
That is divided by 30.
Something.
No, I multiplied that by 30.
Multiply.
What do you
Oh,
want?
yeah. Let's
Sorry,
see.
by 20.
Put this one in the bed.
0.8992.
There was once a time where I almost
1, 2.
became a lesbian.
4, yeah, so 1.
And I'm going to subtract that from.
2 minus. I don't feel like that.
0.11076.
0.111 grams left over.
Wait, what was the number? Oh, because. Are we not still rounding to 4?
The rule for subtracting and adding is different, right? So instead of counting sig figs, we round to place values. So the least precise is the thousandths place as opposed to the 10,000ths place, so we round to the thousandths place. That's the rule for adding and subtracting. So how much is left over? 0.111 grams of oxygen. And that, my friends, is the story of chemical reactions.
Oh, finally, I didn't think I was gonna make it.